So now we're going to do question 4. In 4.1 we are given this function here of h of x being equals to minus 3 over x minus 1 plus 2, right? So in 4.1.1 we are asked to write down the equations of the asymptotes of h, right? So having h of x being equals to minus 3 over x minus 1 plus 2. So the equations of asymptotes, we have the vertical asymptote being equals to 1 and the horizontal asymptote being equals to 2. So these are your asymptotes. And then now 4.1.2 says that determine the equation of the axis of symmetry of h that has a negative gradient. So for us to identify the equation of symmetry, we have our h of x being equals to minus 3 over x minus 1 plus 2, right? And the axis of symmetry that are negative, m must be equals to negative 1, right? So our equation will be mx plus c, where our m is equals to negative 1, so it's going to be y is equals to minus x plus c. So y is the negative asymptote, the negative axis of symmetry rather, negative 1. Let's say for an example excuse me, let's say for an example you have your Cartesian plane like this, and you have your graph, your hyperbola, and this is your hyperbola. So your axis of symmetry passes through here. So this, because it's going down, it's going to be a negative axis of symmetry because it's dividing the graph into two equal parts. So the gradient for this would be equals to negative 1. But there's also another axis of symmetry that passes through in this form, which is increasing. So the gradient for this one will be equals to 1. So the gradients are always these values here, right? So the increasing axis of symmetry is equals to 1, positive 1. The decreasing axis of symmetry is negative 1, right? So hence here we chose negative 1 because we are asked to find the negative gradient, the one with the negative gradient, right? Axis of symmetry. So, and another thing that you need to note is this point here, right? So when you identify your equation of axis of symmetry, you're going to use a point which is where your vertical and horizontal asymptotes intersect. You see, this is the point where your asymptotes intersect. Why am I saying that? Looking at this graph here, let's say it's f of x, right? The asymptotes are traveling here at the axes, right? And another one is traveling here, right? So hence here we would say it's 0 and 0, right? So meaning that if you were to find the equation, you were to use the point of 0 and 0. So now going to our question that we are given, so we now know that the gradient, because we're talking of a negative axis of symmetry, the gradient is supposed to be negative 1, right? So we just indicated that it's negative 1, fine. So now we need to use the points, 2 points. So we have our asymptotes. Our vertical asymptotes equals to 1. Our horizontal asymptotes is equals to 2. Right? So we're going to use that as a point to find this value of c here. So we're going to use this 1 and this 2 as a point. So we're going to substitute, this is x, this is y, substitute in this equation here. So where there's y, you're going to put 2 is equals to minus, where there's x, you put 1 plus c. So it's going to be 2 is equals to minus 1 plus c, and then transpose the minus 1 to the other side. We have c being equals to 3, right? So now you have c is equals to 3. Your equation is y is equals to mx plus c, where your m is equals to negative 1 because it's a negative axis of symmetry. Your c is equals to 3, so you're just going to substitute that. It's going to be negative x plus 3, right? So it's just going to be plus 3 here. So this is your equation of your axis of symmetry, the negative gradient axis of symmetry. now 4.1.3 we are asked to sketch the graph of H showing all asymptotes and intercepts of the axes. So what we're going to do is, we know our vertical asymptotes x of v is equals to 1 and y of horizontal asymptotes equals to 2. And another thing that's important is for us to find the y-intercept when x equals to 0, x-intercept when y is equals to 0, right? So we know that our h of x is given as minus 3 over, so this is 3, let me write it nicely, so it's minus 3 over x minus 1 plus 2, right? So let's find the x-intercepts when y is equals to 0, so it's going to be 0 is equals to minus 3 over x minus 1 plus 2. Transpose the 2 to the other side, we have minus 2 is equals to minus 3 over x minus 1, right? And we cross multiply, minus 2 into x minus 1 equals to minus 3. Divide by minus 2 both sides, we have x minus 1 is equals to 3 over 2. Transpose the 1 to the other side, you have x equals to 3 over 2 plus 1, right? So we're going to have x equals to 5 over 2. So this is your x-intercept, 5 over 2 and 0. So now find your y-intercept when x equals to 0. So you have h of 0 is equals to minus 3 over 0 minus 1 plus 2. And you'll have minus 3 over minus 1 plus 2, which is equals to 3 plus 2 equals to 5. So your y-intercept is 0 and 5, right? So now you have your intercepts, which is let me indicate here. So your intercepts, you have your intercept of 0 and 5 and 5 over 2 and 0, and then you have your asymptotes, which your vertical asymptote equals to 1, horizontal asymptote is equals to 2. So now you can draw your hyperbola, right? So you're just going to draw. Remember that the equation is given as h of x is equals to minus 3 over x minus 1, so plus 2, right? So this a value of minus 3, so this is the a value, which is minus 3. It tells us which quadrant our hyperbola is going to be. So if these were the asymptotes, it's going to be in the second and fourth quadrants, right? So you need to expect our hyperbola to be in the second and fourth quadrant of our asymptotes. So what we're going to do is we're going to indicate our asymptotes in the graph. So we're having our vertical asymptote being equals to 1. So let's say this is our vertical asymptote, x equals to 1. Our horizontal asymptote being equals to 2. So this would be our y equals to 2, right? And then we're having our y-intercept here being 0 and 5. So let's say 0 and 5 is somewhere here. And so this is the asymptote going up. And then let me remove this. So, and then so this is oh, excuse me. So now we have our y-intercept here, which is 0 and 5. So as y-intercept is 5, and this is our asymptotes, right? The blue line going up, it's our vertical asymptotes. And then now we going to write down another intercept, which is this one here, 5 over 2, which would be somewhere here, right? So now these 2 points, as I indicated, they are telling us where our graph should be. So meaning our graph will look something like this and like that. So they won't the graph won't touch the asymptotes, right? The blue lines that you can see here. So this is the graph of this problem here, where you need to indicate your axes, right? So this would be your y and this would be your x. Now in 4.2 we are given the graph of f. This is the equation of the graph of f, right, and the graph of G, and we are told that A is the turning point of F. So if we look at this, at the graph of F, right, and A is the turning point of F, right, and we are also told that the axis of symmetry of F intersects the x-axis at E, right, and then the line G at DM, right, so there is DM there, and this is your axis of symmetry, right, of F, right, because it comes down from your turning point. And then what do we have? C is the y-intercept of F and G, which is this point here. Cool. So there is your graph, and let's answer the questions that follow. So having 4.2.1, write down the coordinates of A. So we need to write down the coordinates of this turning point here. So we're having our equation. This is the equation that we're given. Basically the coordinates is just these values here, right? So we're having 5 and 8 here. So our f of x, so to find the coordinates of A, because we're writing them down, it's going to be minus 5, because here we have x plus 5. X plus 5 equals to 0, so you transpose the 5 to the other side, we have x being equals to minus 5. So it's going to be minus 5 and minus 8. So these are your turning point of this graph of F. So hence the turning point are actually the A value. So now we're done answering this question here. And then 4.2.2, write down the range of F. So we are having this function here, and we just identified the coordinates of A, right, to be minus 5 and 8. So we have minus 5 and is it positive 8? No, it's negative 8, minus 8, right? And to find the range, so the range is talking about the y values. So when you talk of the range, we want to interpret the y values, the movement of y values, right? If this is the y-axis and this is the x-axis, to interpret the movement of y values of this graph of F, right, we know very well that the y values come from a positive infinity, goes down to this minimum point here of minus 8. Remember, we are looking for the y values, and then it goes up to another positive infinity. So there's two ways to write down the range of this function here. You can simply say y is greater or equals to minus 8. Why are we saying equals to? Greater or equals to? Because the equal sign means now that the minus 8 is part of the graph, so hence we're putting the equal sign, right? Or someone can just write from positive infinity to 8, right? This would be solid, this would be like that. So positive infinity, and so this is minus 8, by the way, minus 8 to positive infinity. So someone else can write it like this, it will still be correct. We know that here it's minus 5 and minus 8, right? So to find the values of D, which is M and N, right? And this M here is actually this same X. M is actually equals to minus 5. Why am I saying that? Is because this is the axis of symmetry of the parabola, right? So whatever X value is here, it's the same as the X value that is there. So we are done finding this M being equals to minus 5. So now we need to find this N, right? So to find this N, you can simply use, because the D point touches the straight line. So this is a straight line, right? It touches the straight line, so meaning you can use the equation of the straight line to find the value of N, right? So the equation of the straight line is this one here. G of x is equals to half x plus 9 over 2. So you can simply use that one. G of x is equals to half x plus 9 over 2, right? So the m value here, this m value is actually the x value, so you can simply substitute it. Minus 5 equals to 1 over 2 into minus 5 plus 9 over 2, right? You're just going to substitute that into the equation, and the answer that you're going to get is 2. So therefore our n value is equals to 2, right? So that is the value of m and n. So this is the value of m, this is the value of n. Then in 4.2.4 we are asked to find the area of OCDE. So for us to find this area, so we want the area of DE, right? So we want to find the area of this shape here, which looks like, yeah, it is a trapezium, right? So the D we now know is actually D being equals to our m value we found to be minus 5 and our n value is 2, right? So what this means is from this E to D, the height from E to D is actually 2. So from here to here is 2 units, and then here this point, it's going to be the y-intercept. So what's the y-intercept of the straight line or the parabola? It's 9 over 2, right? It's 9 over 2, so you can simply write 9 over 2 there, and this distance here from O to E we know it's going to be 5, right? Yes, it's minus 5, but because we are writing it in units form, we're just going to say it's 5. So if I were to just write down this shape here, let me do this. So if I were to write down the shape of this trapezium, it's going to look something like this, right? Where this small part here and this large part and this distance here. So this is 5 units. Let me write it nicely. So this is 5 units, and this is 9 over 2 units, and this is 2 units, right? So let me just confirm. Yes, looking at the diagram, yes. So now you can just simply find the area of this, right? Because they said they wanted the area of OCDE. So this is O, this is C, this is D, this is E. To find the area of a trapezium is equals to half DE plus CO multiplied by perpendicular height of OE, right? So I'm just writing with respect to the shape. So it's going to be half our small side, which is 2 units, plus our large side, which is our large height rather, which is 9 over 2 multiplied by the base, which is, we normally say it's the perpendicular height, but yeah, this is just going to be saying it's a base of 5 units, right? So punch this in your calculator and you should get an area of 16.25 in decimal form, or you'll get 65 over 4. So, and then 4.2.5, you're asked to determine the equation of the inverse of G, right, in the form y is equals to. So if we go back to the given equations, we can see that this is the equation of G, and we are asked to find the inverse of this equation here, right? So what you're going to do is this. So we have our g of x being equals to 1 over 2x plus 9 over 2, right? And which is y is equals to 1 over 2x plus 9 over 2. So you're just going to swap, so it's going to be x equals to 1 over 2y plus 9 over 2, right? And we're going to transpose this to the other side. We have x minus 9 over 2 is equals to half y, and then we divide everything by half, right? So our y is going to be equals to 2x minus 9, right? So this would be your inverse of the function, which is 2x minus 9. So let me just write this 9 properly here. So it's going to be y is equals to 2x minus 9. So now 4.2.6, we are told that if h of x is equals to the inverse of g plus k, if this is a tangent rather to f, so if this whole thing here is a tangent to f, determine the coordinates of the point of contact between h and f, right? So the point of contact, remember that f is a parabola, right? So the point of contact between this, so let's say this is a parabola and it has a turning point here. Let me use another color. So this is the turning point of this parabola, and if we have this line, the tangent line, then which means it's going to pass like this, right? So the tangent is going to pass and it will touch at one point at the turning point of the parabola, right? So what we need here, we need to identify this point where these two, the graph of h of x and f of x intersects. You know, we need to identify that point, the very same point. So how we're going to do that, we are given that h of x is equals to the inverse of g plus k, right? So, and we know that f of x is equals to, so is equals to 1 over 2 into x plus 5 squared minus 8, right? So if you were to simplify further by expanding this, by doing this, x plus 5 minus 8, if you were to find the product of this, you should get okay, let me just do that. So it's 1 over 2 into x squared plus 5x plus 5x plus 25 minus 8, which would be 1 over 2 into x squared plus 10x plus 25 minus 8. So this half will multiply everything that is inside, and then you collect the like terms, but the standard form of equation that you need to get, it's 1 over 2x squared plus 5x plus 9 over 2. So this would be your f of x in standard form. So what you have now is you're having f of x in standard form of 1 over 2x squared plus 5x plus 9 over 2, right? And you're having h of x, which is equal to the inverse of g plus k. So what is the inverse of g? The inverse of g is equals to 2x minus 9, right? So if f of x is equals to 1 over 2 x squared plus 5x plus 9 over 2, and h of x, if you substitute this and put it inside here, h of x would be equal to 2x minus 9 plus k, right? So this is what we are having here, f of x and h of x, right? So for us to find the point where these two meet, right, we need to derive this. So we can derive the f of x and we'll have f prime of x being equals to 1 over 2 times 2x to the power of 2 minus 1 plus 5. So f prime x is equals to x plus 5, right? So this is the derivative of this one here. So and then for the h of x, right, we're just going to derive it. We'll have 2, right? So that's the derivative because these are constants, right? So we are going to say f prime of x is actually equals to h prime of x because they meet at that point, right? The gradients are equal. So instead of writing f prime x, we're going to write this x plus 5. So x plus 5 is equals to 2. So transpose the 5 to the other side, you have x equals to 2 minus 5. And then our x is equals to minus 3, right? So now that we know the x value of the point of contact between these two, we need to find the y value, right? So you can substitute the y value into the original equation. So it can be the original equation of f of x, where it was 1 over 2 into x plus 5 squared minus 8, right? So you can substitute your x value of minus 3. F of x equals to minus 3 equals to 1 over 2 into minus 3 plus 5 squared minus 8, right? So you get a value of minus 6. So this is your other coordinate. So complete coordinate is going to be minus 3 and minus 6. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.